Welcome to this special series on all about bridges, which is called Clause by Clause. In Clause by Clause series, we take one bridge-related specification, or guidelines, or code, or manual, and explain it clause by clause with the help of illustrating visuals. In this episode, we dive deep into the latest RDSO guidelines on HSFG bolts as per latest BS111, Revision 7, issued in July 2023, which is the cornerstone of reliable bolted connections in steel bridges across industry. From updated tightening procedures and inspection methods to critical compliance details, this session explains how the new provisions enhance safety, performance, and durability in steel bridge construction. Whether you're an engineer, site supervisor, or student, this video will help you clearly understand what's new, what's required, and why it matters for every HSFG bolted joint in RDSO standard bridges. This clause-by-clause explanation of BS111 is divided into two episodes. This is Episode 1. In Episode 1, the HSFG bolt assembly, specifications for bolts, nuts, DTI washers, ordinary washers, surface preparations, etc., have been covered clause by clause. In the second episode, installation of HSFG bolts, inspection and checking, calibration, torquing, etc. are covered. Let's start Episode 1. We begin our technical deep dive with the introduction to HSFG bolts. Historically, rivets have been the mainstay for making field connections in steel girders, bearing the weight of both railway and highway loadings. However, the process of riveting demands skilled workers and elaborate equipment and arrangements. As time progresses, securing this skilled labor and the necessary equipment for smaller quantities of work is becoming increasingly difficult, leading Indian railways to actively search for alternatives to the rivet. Furthermore, rivets present a practical challenge in the field, particularly when the grip length increases. Achieving the uniform heating required for these longer rivets, and crucially ensuring they do not cool down before they are properly driven, is a persistent and problematic issue on site. The high-strength friction grip, or HSFG, bolting assembly emerges as one viable substitute option, and it is the subject of these detailed guidelines. The mechanism of the HSFG assembly is fundamentally different from traditional connections. Here, a high-strength structural bolt is meticulously tightened to induce a predefined tension right in the bolt shank. This tension generates immense frictional resistance at the interface between the steel members, or plies, in the joint. It is this friction that prevents the plies from moving relative to each other, unlike an ordinary bolt, which relies on the bolt body bearing against the plate and eventually shearing. The HSFG bolt assembly transmits the shear load along the interface, purely through friction. Scope and reference codes. Moving on to the scope, these guidelines specifically cover the application of HSFG bolts in friction-type joints for bridges addressed by the IRS Steel Bridge Code, supporting sizes from M12 up to M36. While this document serves to help you better understand the codified provisions, it is imperative to remember that for actual design and use, the source codes themselves must always be referred to and rigorously followed. The scope encompasses use in both road-over bridges and railway bridges. Given that IRC codes already permit HSFG assemblies, the final incorporation of HSFG provisions into railway codes will allow them to be used as a full alternative to rivets in all types of railway bridges. However, be warned, due to the distinctly different structural actions, an HSFG assembly must never be used in conjunction with rivets or welds within the same joint without first carrying out a detailed analysis of the structural action. The reference code section highlights a major shift. In previous versions, design and manufacturing relied on IRS and IS codes, only referring to European norms where the domestic codes were silent. With this revision, the manufacturing of HSFG bolting assemblies is mandatorily switched over to the EN14399 series code, System HR. Design, however, is still performed based on the IRS Steel Bridge Code, whose provisions for HSFG assemblies are fundamentally drawn from the IS 4000:1992 code. The reference documents now include various parts of the EN14399 series, covering general requirements, suitability for preloading, the HR system of hexagonal bolts and nuts, plain and chamfered washers, and the direct tension indicator for the assembly. Also referenced are EN1090-2 for the execution of steel structures and the domestic standard IS 4000:1992. HSFG bolting assemblies. Finally, we address the specific requirements for the HSFG bolting assemblies themselves. Preloaded HSFG assemblies are exceptionally sensitive to minute differences in both their manufacture and the lubrication applied. This critical sensitivity dictates that the complete assembly, including the mandatory direct tension indicator washer, must be supplied by a single manufacturer who assumes full responsibility for the function of that entire assembly. Furthermore, the application of hot dip galvanizing or any other surface coating must also be strictly controlled by this single manufacturer. The requirements for the supply and verification of high-strength friction grip HSFG bolting assemblies are exceptionally strict, primarily due to their reliance on a precise force known as preload. But what is preload? The concept of preloading is central to HSFG joints. Unlike ordinary bolts that transfer load by bearing against the sides of the hole, an HSFG bolt is deliberately tightened to near its yield stress before any external loads are applied. This extreme tension in the bolt shank creates a massive clamping force between the connected steel plates. When the bridge is in service, the load is then transferred entirely by the frictional resistance generated by this clamping force at the plate interfaces, which is far more reliable and fatigue-resistant than bearing. Now moving further, the document mandates that DTI washers, direct tension indicator washers, are not to be sold separately, but only as part of a complete assembly that includes the bolt and nut. This entire package must comply rigorously with the standards set out in EN 14399-3. The reason for this standardization is the assembly's sensitivity. Tiny differences in component dimensions, manufacturing tolerances, or even the applied lubrication across different suppliers can drastically affect the resulting preload, leading to joint failure. Therefore, the use of DTI washers is mandatory in all HSFG bolting assemblies, serving as the essential tool for quality control. The final verification of this critical preload relies on the functionality of the complete assembly, not just the individual component's strength. This is confirmed when the average gap remaining after tightening, measured by the compression of the DTI washer's protrusions, is less than the specified values in Table 3. As the bolt is tightened, the force crushes these protrusions, and the remaining smaller gap indicates that the minimum required preload has been achieved. The test methods detailed in EN 14399-2 and EN 14399-9 are the codified procedures developed specifically to prove that the supplied components are indeed suitable for preloading and can consistently deliver this necessary clamping force when installed correctly. In the next section, we observe Table 1, which specifies various requirements of the components that make up the complete assembly, referred to as the System HR. This system is complex, composed of several parts, each defined by a specific part of the European standards. The bolt and nut themselves must conform to EN 14399-3, and these are classified as property classes HR 10.9 or HR 8.8, identifiable by the markings HR 10 or HR 8. But the assembly is more than just a bolt and nut. It also includes various washers. We see that plain washers can conform to EN 14399-5, though these are strictly limited to use only under the nut, or they can be the plain chamfered type, which follow EN 14399-6. Most importantly, the assembly incorporates the direct tension indicator, or DTI, which must comply with EN 14399-9, and this DTI is used in conjunction with special nut face washers or bolt face washers. Overall, the entire system's performance is governed by the general requirements laid out in EN 14399-1, and its ability to achieve the desired tension, its suitability for preloading, must be tested according to EN 14399-2. Moving on, we look at a section defining the type of HSFG bolting assemblies with DTI. The core mandate here is that the bolt and nut must fully comply with all aspects of EN 14399-3 for the HR system. However, their functional characteristics are only established when the assembly is tested together with the direct tension indicators. This testing requirement is critical because performance depends on the interaction of all parts. The assembly is permitted to include supplementary washers, either those conforming to EN 14399-6 or EN 14399-5, again with the latter only under the nut, along with the specific face washers defined in EN 14399-9. The figures shown later in the document, specifically Figure 2 and Figure 3, are intended to illustrate the correct codified assembly configurations when using direct tension indicators. Now let's have a closer look at Figure 2 and 3 provided in the document. BS1-1-R7 provides detailed diagrams on how the HSFG bolt assembly is to be put together and how its performance is finally verified. It clearly delineates two main procedures for tightening: the normal method of assembly and the alternative method of assembly. The normal method involves tightening the joint by rotating the nut, and this process is shown with two possible configurations. The DTI can be placed in an under-bolt head fitting or in an under-nut fitting. The alternative method involves tightening by rotating the bolt head, and this procedure similarly allows for both under-nut fitting and under-bolt head fitting. For each configuration, a key defines the individual parts, including the necessary DTI, the specific nut face or bolt face washers, and the standard washer. Crucially, each diagram points to the gap, which is the physical space measured after tightening, used to verify the preload. Now let's turn our attention to the text describing the functional characteristics of the complete assembly. This characteristic is a measurement of the overall performance of the integrated system: the bolt, the nut, the DTI, and any washers. To check this, a mandatory test procedure must be performed where two essential parameters are measured as the assembly is tightened: the relative rotation that occurs between the nut and the bolt, and the resulting bolt force achieved. This test procedure is based on EN 14399-2 standards, but has been adapted specifically to accommodate the presence and function of the direct tension indicators. The next section talks about suitability tests for preloading with direct tension indicator in an assembly. Direct tension indicators conforming to EN 14399-9 are suitable according to EN 14399-2, provided they are used in an assembly comprised of matched components in accordance with Table 1 and with EN 14399-3 System HR that have been tested in accordance with EN 14399-2 to determine the relative rotation between the bolt and nut. It further says that type tests shall be carried out separately for the direct tension indicator under the bolt head and under the nut. The type test shall be used to demonstrate that delta theta 2, measured with assemblies incorporating a direct tension indicator, exceeds the appropriate delta theta 2 minimum by at least 10%. But so far, guidelines have not explained what is delta theta 2. In the context of the EN 14399-2 standard, delta theta 2 refers to a specific and critically important rotational measurement taken during the bolt suitability test. It is the difference of two angles. First angle is taken at the point at which the bolt force first reaches the minimum required preload value. The second angle is taken at the point at which the test is stopped, representing the maximum angle of rotation before failure occurs. Difference of these two is delta theta 2. It is a key parameter used to verify that a high-strength structural bolting assembly has sufficient ductility and a reliable tightening margin. Now let's dive right into subsection 4, which discusses the suitability test for establishing bolt force. This is a crucial step. The document states that the test must be carried out in a calibrated load cell using the requirements specified in EN 14399-2. If we need to make adjustments to the length of the bolt head and nut assembly, we'll use shims, as they are also specified in EN 14399-2. Now pay close attention to the assembly. It needs to be put together according to Figure 2A. Most importantly, the required bolt force, or FBI, must be determined following Table 2 of EN14399-9. And here's the kicker. This force must never be less than the minimum bolt force specified in Table 4 of EN14399-9. That's how we establish the required initial tension. Moving on to Section 5, titled Bolts. This part is all about the bolts themselves, specifically for HSFG connections, meaning high-strength structural friction grip connections. We are looking for high-strength structural bolt systems that conform to the requirements for preloaded joints. This includes the nuts and the nuts of System HR, which are suitable for preloaded joints with wide seating surfaces or washers, as specified in EN 14399-3. This entire system, the bolt, nut, and washer, must comply with EN 14399-1 and 14399-2. The general requirements, threads, mechanical properties, tolerances, finish coatings, surface integrity, and acceptable features are all detailed in Table 3 of EN 14399-3. Finally, EN 14399-3 specifies that these bolts must belong to one of two property classes, 8.8 or 10.9. Property class now, let's break down the most important characteristics, starting with subpoint I, the property class. Every property class has two parts, separated by a decimal point, for example, 8.8. The first part, represented by X, indicates 1/10 of the nominal tensile strength in Newton per square millimeter. The second part, Y, tells us that the ratio of the lower yield stress to the nominal tensile strength is 10 times the number. So for a property class 8.8 bolt, the nominal ultimate tensile strength is 800 newtons per square millimeter. The lower yield stress ratio is 80% of 800 newtons per square millimeter, which comes out to be 640 newtons per square millimeter. This is a fundamental concept for understanding the strength of the bolt. Identification and marking. Next up is subpoint 2, covering identification and marking. All high-strength structural bolts must be manufactured and marked according to EN 14399-3. There are two parts to this marking. First is the property class marking, which must be done with the letters HR, for instance, 8.8 HR or 10.9 HR. Second is the identification mark of the manufacturer of the bolting assembly. This mark must be visible. For traceability, we also need an embossed or indented heat mark on the top surface of the bolt head. Additionally, the heat mark, the name of the manufacturer, and the property class of the material must be embossed on the bolt head, nut, and washers. Diameter and length. Let's look at subpoints 3 and 4. Subpoint 3, the diameter, is straightforward. Table 2 of EN 14399-3 gives us the precise dimensions for the bolt's diameter. Moving to subpoint 4, the length is where we need to be careful. The bolt length we choose must ensure that after tightening, the following requirements are met for the bolt end protrusion beyond the nut face and the overall thread length. Requirement A states that the length of the protrusion must be at least the length of one thread pitch when measured from the outer face of the nut to the end of the bolt. Requirement B, which applies specifically to preloaded bolts following EN 14399-3, is that at least 4 full threads, excluding the thread runout, must remain clear between the bearing surface of the nut and the unthreaded part of the shank. Surface finish and coatings. Finally, let's examine subpoint V, surface finish and coatings. For property class 8.8 bolts, the standard finish is hot dip galvanized according to ISO 10684, the latest version, to provide the necessary salt spray resistance for the site conditions and environment. However, this hot dip galvanization should not be used for property class 10.9 bolts because it can cause hydrogen embrittlement. Instead, property class 10.9 bolts should be coated with zinc flakes according to ISO 10683, the latest version, to ensure adequate salt spray resistance for their specific site condition. However, depending on the site conditions, locations of the bolts in the structure, and corrosion proneness, Use of zinc flake spray coating as per ISO 10683, latest version, can be adopted even for property class 8.8 bolts as well. We are now looking at Section 6, which focuses entirely on the nut used in these high-strength structural bolting assemblies. General requirements for nuts. To begin, for high-strength structural friction grip HSFG connections, we must use only high-strength structural nuts that meet the requirements for assemblies of high-strength structural bolts and nuts of the system HR. This system is specifically designed for preloaded joints with wide seating surfaces, as detailed in EN14399-3, and must be used along with EN14399-9-1 and 14399-2. The general specifications for nuts, including their reference standards for material, threads, mechanical properties, tolerances, finish coatings, and surface integrity, are provided in Table 5 of EN14399-3. A crucial practical requirement is that the nuts must run freely on their partnering bolt, which should be checked by hand assembly. Any nut and bolt assembly where the nut doesn't run freely must be discarded. If you're using a power tool for tightening, the document gives 2 additional checks. A. For every new batch of nuts or bolts, their compatibility must be verified by hand assembly before installation. And B. For already mounted bolt assemblies, a sample of nuts may be checked for free running by hand after an initial loosening. These nuts must also meet the specific characteristics detailed next. Property class of nuts. Let's discuss subpoint I, the property class of the nuts. Nuts are designated by a property class that's equal to 1 by 100 of the minimum tensile strength in newtons per square millimeter of the bolt. For HSFG bolting assemblies, the property classes required are 8 and 10, as specified in EN 14399-3. The rules for mixing classes are strict. A property class 8 nut can only be used with bolts of property class 8.8. However, a property class 10 nut is more versatile and can be used with bolts of property class 8.8 and 10.9 both. The physical dimensions of these nuts are provided in Table 4 of EN 14399-3. Identification of nut. Moving on to subpoint 2, the identification of nut. All high-strength structural nuts manufactured according to EN 14399-3 must have specific markings. This marking includes A. The property class marking with the letters HR, for example 8HR or 10HR, and B. The identification mark of the manufacturer of the bolting assembly. As shown in Figure 5, these markings must be either indented or embossed on the non-bearing face of chamfered nuts or on the other bearing face of chamfered nuts. Surface finish and coatings of nut. Next is subpoint 3, concerning the surface finish and coatings of the nut. Similar to bolts, HSFG nuts of property, Class 8 should be hot dip galvanized according to ISO 10684, the latest version, to provide necessary salt spray resistance depending on the environment. However, just like with the high-strength bolts, property Class 10 nuts should not be hot dip galvanized to avoid the risk of hydrogen embrittlement. Instead, these nuts must be coated with zinc flakes as per ISO 10683, latest version. The document notes an important exception. Depending on the site conditions, locations in the structure, and corrosion risk, the zinc flake spray coating can actually be adopted even for property Class 8 nuts. For the threads, in the case of hot dip galvanization, the threads must be produced to tolerance Class 6AZ as per ISO 261, ISO 965-2, and ISO 965-5. For all other types of coatings, the threads should be to tolerance Class 6H as per the same ISO standards. Position of nut and bolt. Finally, subpoint 4 covers the crucial practical requirement for the position of the nut in the bolt assembly. The nut should be placed in a position that makes it less accessible to be opened by unauthorized or antisocial elements, as the document states. An HSFG bolt assembly can't be easily opened without a torque wrench, but as an additional precaution, the preferred nut positions are A. In a girder web, the nut should face towards the outside of the girder. B. In flanges, the nut should be towards the bottom, unless in composite construction. C. In composite construction, the nut should face towards the inside of the concrete. D. In bracing, the nut should face towards the rolled section side so that the space needed to rotate the nut is not readily available. And E. When a tapered washer is used, the nut should preferably be on the other side from the washer. Holes for HSFG bolts, Item 7 in subpoints 2 and 3. The first section discusses the requirements for holes used with HSFG bolts, stating that normal holes shall be used. Making of holes. The holes must be made exclusively by drilling. Nominal diameter of hole, 2. The actual diameter of the hole depends on the bolt diameter. For bolts with a diameter of less than 25 millimeters, the hole diameter is 1.5 millimeters more than the bolt diameter. For bolts 25 millimeters and larger, the hole diameter is 2 millimeters greater than the nominal bolt diameter. For example, a 20 millimeter diameter HSFG bolt requires a hole 21.5 millimeters in diameter. Oversize holes. 3. Oversize holes are only permitted when existing structures are being connected. The maximum size of the hole is limited to 1.25 times D or D plus 4, whichever is lesser, where D is the bolt diameter. For example, for 16 millimeter dia bolt, the maximum diameter of hole shall not exceed 20 millimeters, and for 24 millimeter diameter bolt, the maximum diameter shall not exceed 28 millimeters. Plain and chamfered washers, Item 8. This section details the use, placement, and characteristics of washers with preloaded HSFG bolts. Plain and chamfered washer. Washers used under heads of preloaded bolts shall be chamfered according to EN 14399-6 and positioned with the chamfer towards the bolt head. Washers according to the EN 14399-5 shall only be used under nuts. Washers according to EN 14399-5 and EN 14399-6 are not intended to be used in direct contact with oversized or slotted holes. Specification and reference standards for plain washers and plain chamfered washers regarding material, general requirements, mechanical properties, tolerances, finish coatings, workmanship, acceptability, etc., has been given in Table 3 of EN 14399-9-5 and EN 14399-6, respectively. Dimensions of plain and plain chamfered washers have been given in Table 2 of EN 14399-5 and EN 14399-6, respectively. Plain washers, or if necessary, hardened taper washers, shall be used for HSFG bolting assemblies as follows. A. For 8.8 bolts, a washer shall be used under the bolt head or the nut, whichever is to be rotated. B. For 10.9 bolts, washers shall be used under both the bolts and the nut. Plate washers shall be used for connections with long slotted and oversized holes. One additional plate washers, or up to 3 washers with a maximum combined thickness of 12 millimeters, may be used in order to adjust the grip length of bolt assemblies. They shall be placed on the side that is not turned. Dimensions and steel grades of plate washers shall be specified. They shall not be thinner than 4 millimeters. Taper washers shall be used if the surface of the constituent product is at an angle to a plane perpendicular to the bolt axis of more than A. 1 by 20 or 3 degree for bolts with D less than or equal to 20 millimeters, B. 1 by 30 or 2 degree for bolts with D greater than 20 millimeters. Dimensions and steel grades for taper washers shall be specified. The washers have the following characteristics. Number 1. Identification. Hardened and tempered plain washers shall be marked with at least manufacturer's identification mark in letter H. Alternatively, these may also be marked with HR in place of H when supplied as component of bolting assembly of system HR. Marking shall be indented on one of the bearing surfaces. The marking of washers with enlarged outer diameter shall be HD. Similarly, for hardened and tempered chamfered washers shall be marked with at least manufacturer's identification mark in letter H. Alternatively, these may also be marked with HR in place of H when supplied as component of bolting assembly of system HR. Marking shall be indented on non-chamfered side. Number 2. Surface finish and coatings. Washers as per EN 14399-5 and EN 14399-6 can be hot dip galvanized as per ISO 10684, latest version, to provide salt spray resistance suitable as per site condition, depending upon severity of environment. However, attention is drawn to the need to consider the risk of hydrogen embrittlement when selecting an appropriate surface treatment process, e.g. cleaning and coating, as per relevant coating standard. So these washers can also be coated with zinc flakes as per ISO 10683 to provide salt spray resistance suitable as per site condition, depending upon severity of environment to avoid risk of hydrogen embrittlement. Now let's move forward to next para 9, which is about DTI washers. 9. Direct tension indicators, DTI washers. Compressible washer type direct tension indicators, DTI, as per EN 14399-9, known formerly as load, indicating washers, used in conjunction with bolt and nut face washers, are a load indicating device which are placed under the bolt head or under the nut. The direct tension indicators have protrusions on one face which compress under load and thus may be used to indicate the magnitude of the preload in the assembly. Salient features of DTI as per EN 14399-9 are as below. Dimensions of DTI. Before installation, the dimensions and tolerances of compressible washer-type direct tension indicators shall be as given in Table 2 of EN 14399-9. The size and number of protrusions on the direct tension indicator shall be sufficient to meet the performance requirements of Clause 3.3 of EN 14399-9, and their number shall be not less than 4. The protrusions on a direct tension indicator shall be spaced at equal angular intervals. The shape of the protrusions is at the discretion of the manufacturer. 2. Specifications and reference standards for DTI. Specifications and reference standards regarding material, general requirements, heat treatment, maximum hardness, surface finish, associated bolts and nuts, associated washers, acceptability, etc., have been given in Table 3 of EN 14399-9. 3. Performance test of DTI. The direct tension indicators shall be tested on a calibrated load measuring device as per description given in Clause 3.4 of EN 14399-9 for the test procedure. The load requirement of Table 4 of EN 14399-9 shall be met when the direct tension indicators are compressed to the average gaps given in Table 9 of EN 14399-9. Samples of direct tension indicators shall be tested by the manufacturer after the final production process, including the surface finish, if any. The minimum number of direct tension indicators tested per manufacturing lot shall be 8, and all samples shall pass the test. 4. Marking of DTI. Direct tension indicators shall be marked with the identification mark of the manufacturer of the assembly in H8 or H10 as appropriate. The marking shall be indented into the direct tension indicator face from which the protrusions project. It is recommended to stamp lot numbers on the face of the direct tension indicator. Nut face washers and bolt face washers. Dimensions and tolerances of nut face washers and bolt face washers shall be as given in Table 6 and 7 of EN 14399-9 respectively. Specification and reference standards for nut face washers and bolt face washers regarding material, general requirements, heat treatment, hardness alternatives, tolerances, surface finish, associated bolts and nuts, associated washers, acceptability, etc., have been given in Table 8 of EN 14399-9. Nut face washers shall be marked with the identification mark of the manufacturer of the bolting assembly and the letters HN. The marking shall indent it into one face. Bolt face washers shall be marked with the identification mark of the manufacturer of the bolting assembly and the letters HB. The marking shall indent it into one face. 6. Surface finish and coatings. For corrosion protection of DTI, nut face washers and bolt face washers, Hot dip galvanization should not be done, because in case of hot dip galvanization, it is difficult to accurately control the thickness of coating as well as risk of hydrogen embrittlement. Moreover, excessive coating of DTI washers may lead to erroneous tensioning of HSFG bolt assembly. Hence, in DTI, nut face washer and bolt face washer, surface finish should be Sheridized according to EN 13811, or zinc flake coating as per ISO 10683 should be done. 8. Functional characteristics of DTI and bolting assembly. A specified feeler gauge as per Table 9 of EN 14399-9, which is reproduced below, shall be used to determine that the required bolt preload has been achieved by the assembly after it has been tightened. DTI washer shall have indentation mark or other features on the outside diameter that correspond to and are aligned with feeler gauge entry spaces to indicate where feeler gauges shall be inserted. Tests have shown the need for a smaller gap when the direct tension indicator is used under the rotated component. Direct tension indicators fitted as specified will result in the same loads being attained when the bolts are tightened to the specified gaps. The average specified indicator gap shall be determined using the following measurement procedure. The feeler gauge shall be used as a no-go inspection tool. The feeler gauge shall be pointed at the center of the bolt as per Figure 9 of EN 14399-9 and shall refuse to enter the number of refusal spaces specified in Table 10 of EN 14399-9. Let's move on to the next para, that is para 10, surface preparation for steel interface before providing HSFG bolts. The steel interface between the plies which form a joint having HSFG bolts shall have special surface preparation so that sufficient slip factor as assumed by designer in design is available. The surface preparation shall be assumed by designer in design based on slip factor specified in Table 13 of the IRS Steel Bridge Code. For ready reference of our viewers, this table is being reproduced here. The following surface preparation shall be done. 1. For new construction, the interface between the plies which are connected together by the HSFG bolts shall be aluminum metallized without any overcoating. The aluminum metallizing shall be as per para 39.2.1 of IRS B1. It means that after metallizing, no further coats of primer and aluminum paints shall be provided on the contact surfaces of the plies. 2. For existing structures, the interface of plies which are to be included in the HSFG bolts shall be cleaned by wire brushing/flame cleaning equivalent to the surface specified in IRBM, paragraph 217, 1B, I2, IV. For ready reference of our viewers, this is being reproduced here. The surfaces shall be cleaned to remove all loose rust and paint layers. Only isolated patches of coating/rust can remain. If, however, in existing structures, rivets are to be replaced by bolts but no surface preparation is possible, the slip factor shall be suitably reduced. With this, our episode 1 ends. For rest of the guidelines, please watch episode 2. Tell us in comments section the topic on which you want to watch a video. Subscribe for more such content.